The relationship between velocity and acceleration is the same as the relationship between position and velocity. We'll start with instantaneous acceleration. The definition of instantaneous acceleration is dv over dt. This is the derivative of velocity over the derivative of time, symbolized by v dot. If we look at the example on the left of 3t squared, then our instantaneous acceleration equals 6t. Oftentimes we also write down the connection between the acceleration and the position because it's the derivative of velocity. Acceleration is then the second derivative of position, x double dot. The two dots being for second derivative, whereas one dot is first derivative. We can also write that as d squared x over dt squared. So this is the instantaneous acceleration, 6t. And we can also talk about the average acceleration, a line. Again, the line being for average. The equation is delta v, change in velocity, over delta t, the change in time. In other words, this is your terminal velocity minus your initial velocity over the change in time. By this we mean your terminal time minus your initial time. In the same way that we calculated our instantaneous acceleration, we can now calculate our average acceleration from the left. So our average acceleration over the time 1 second to 3 seconds equals the change in velocity between those two times, vt3 minus vt equals 1, over the change in times, 3 minus 1. If we calculate this, we get 3t to the second is 27 minus 3 over 2. And our units here are meters over seconds squared. Of course, with the understanding that we're measuring in meters for distance and seconds for time. And now we've calculated our average acceleration. And if you want to calculate it out all the way, you get 12 meters per second squared. And you also have your instantaneous acceleration, which is dependent on time. Now, just like with velocity, if your acceleration, your average acceleration is measured over a different time, your results will change. And of course, just like with the velocity, if your acceleration is constant, then your average acceleration will be the same as your instantaneous acceleration. You'll have a constant velocity in scenarios where x is equal to t squared. For example, x equal to 4t squared plus 3t plus 5.